So in this video I have some code for implementing the black model, and I have some VBA code for implementing a binomial model that replicates the valuation of the black model for the European option, but also can be used to estimate the American option as well. So there is this paper by Chaudhury, some easy to implement methods of calculating American futures options prices, and it's from the Journal of Future Markets, 1995, and a few models here are implemented. And there's discussion around the futures, the exercise, the time period, risk, and then some notation for the American option, capital C for American, lowercase c for European, capital P for American, lowercase p for European in turn. And it's the model is our classic geometric Brownian motion, and we have the formula for black, call and put, and then there's some additional models that are implemented here. Also analytical solutions suggested by Kim, Gask, Johnson, 1984. There's an additional method here, Macmillan, Barron, Adesi-Whaley, I suspect, approximation for early exercise using the quadratic approach. And then there's some tables further along with implementation of results for the option pricing. So if we take a look at some of the numbers here initially, the numbers that I have, we have a couple of implementations. I've copied table 1, I think it's table 1 I have here in an Excel spreadsheet. I've copied actually it's table 2, and the implementation I have here is for there's a binomial model, and it's pricing an American put, capital P, and there's European value here as well. So just to take the first estimation here, if the futures price was 100, maybe we can make this a little bit bigger. If the futures price was 100, and the time period was equal to 0.2, let's just check this, 0.25 years, so 3 months. The volatility was 20%, and the risk-free rate was 8%, and the exercise was equal to 100, then if we had run a European option, a European put at, let's take 750 steps as here, 750 steps. Okay, so I'm just going to change A to E. A goes to E for European. Then, and we run this code. Okay, see what value we get. I'm going to pause for a moment. Okay, we get 390.07. 390.07, which is very close to this 391. In fact, rounding makes 391. In addition, for the American option, we have 392 using those same parameter values. And note that the number of steps here in the tree, if we could find the number of steps, I'll pause for a second, find that number of steps. Okay, I suspect it's here. Number of steps, we come down. If we take a look here, the values are computed using binomial method with 750 time steps. Okay, let's go back into the spreadsheet for a moment, and we run the estimation for the American option, American option, again using a binomial. We'll have a look at the code. Let's pause for a second. Okay, the result we get now is a little bit higher, it's 392. And we compare here with the American 392. And what's code do we have? Well, the code here, if we go into Visual Studio for a second, I basically used a Cox Ross Rubinstein tree based on code obtained from Fabrice Roux. Okay, so the original source code I took as code from Fabrice Roux. It was for a spot where initially we had used we had a specification for a spot price as opposed to futures price. I made just one small change to the code in that I adopted P, the risk neutral probability, for the American futures, or for the binomial model here, where instead of E negative R minus Q, I just substituted in here for 1. Otherwise, the way we generate the tree, in fact we have a futures tree, so I don't use spot as would have been suggested in the original code, F, and then I build a futures price tree. So in fact the spot was taken out and replaced with F, and F here is the futures price, and then there's a futures price tree that's constructed on the back of this F, and then we run implement the intrinsic valuations for both call and put. And then we'll expand the screen here a little bit. There's an option here for call and put for the European option, and then for the American option. In the case of the American option, we have to subtract, we have to decide which value is greatest, the stopping value or the holding value. Okay, and again for the put option here, for each node we've got to discern which is greatest, the stopping value or the holding value for the option. Okay, so let's go back in again to the tree and see if we can replicate the set of results that were obtained here. So what differs here in this table 2 is we have a range of different future prices. I have those same future prices here, and what I'm going to try and do is run a data table where I implement the function CRR tree F, and then we take the futures price, the exercise, the time, the risk, the volatility, the number of steps, 750, consistent with what's specified here for the put option, and it's American. Okay, so let's open this up to running a data table. We come here to the data tab. We look for what if analysis, data table. Is it a column or a row? It's a column of data. And then what in the original parameter inputs specifies the futures price. It's F here. And then we just hit OK, and it will take a second or two. So I'll pause and let that execute. And then when the values calculate, each time there's 750 steps being estimated. When the results appear, I'll continue to record. And we've obtained results from the data table. Now what I'm going to do here is just copy this, edit, copy, and then paste special, so that when I reopen this particular workbook again, I just get the values appearing and that the table doesn't calculate itself. But if we notice here for the American put option, with values of F going between 80 to 120, the estimates of 20 when the futures price is 80 is consistent. 1059, 1058, 6 with 90, futures of 90, so that tallies with a futures price of 100. The value of the option is 399, 392, 392, 392 when the futures price is 110. The binomial futures value is 94, 94, and for 120 when the futures price is 120, the value of the futures is 0.144. So the values are consistent, and that would tend to indicate that the code that we're running here, I can check the code that I'm running here based on original Fabrice Roy code from the original Volupta website with some modifications added in, with the new modifications of adopting for the futures price instead of having a spot and changing P to 1 minus D over U 1 minus D, where P here denotes the risk neutral probability. Otherwise leaving, other than this change here, otherwise leaving the code pretty much intact, then the value that I get stemming from this VBA code, which I will leave in the link below the video, the value that I obtain from this code is in line with what's obtained in the literature. And again, just a reminder of where I obtained the paper from. The author here was Chaudhury. The journal was the Journal of Futures Markets, and the paper was published in 1995.